Hello, everyone, and welcome back to our channel, Tutoring Made Easy. I hope each and everyone is doing great. The goal of this channel is to make tutoring very easy and enjoyable. Please, if you haven't yet subscribed to our channel, please do us a favor by subscribing so we can grow this channel together. If you have already subscribed, thank you for supporting the channel. On the other hand, if you have specific tutoring topics you would like us to do a video on for you, please feel free and drop it in the comment section below, and we'll be more than willing to do that. In today's video, we shall be looking at mathematics and the topic calculus. Did you know that Sir Isaac Newton is considered the father of calculus? Yes, so the father of calculus is Sir Isaac Newton. Sir Isaac Newton. And also, he's the same person who invented gravity under the apple tree. So calculus is credited to Sir Isaac Newton, and he's the same person who is behind gravitational force, inventing gravity while he was sitting under the apple tree. Calculus can be broken down. So we have calculus. We can break that down. Into two categories. We have what we call differentiation on one as a category, differentiation as one category, and then the other part is integration. Yes. Now, one may ask, what is the importance or the significance of calculus? So we need calculus, okay? So we need calculus. We need it so that we can estimate, okay? We need calculus to estimate the slope or gradient of a nonlinear expression or function. So when we are given any expression or function and we want to estimate slope or gradient of those expressions and functions, we need calculus to do that. Do you remember, I don't know whether you remember this, but do you remember when we're looking at the linear function or the linear expression, all right, where we said that for every linear function, we have what we call y is equal to a plus bx. You remember? And we said we can draw the linear function as follows, this way. Sorry. It's a linear function. So like this way. Do you remember? And we said that imagine you have a point here, which could be a point here, which could be y1. So let's imagine this point here. This point here is the point y2. And then let's also imagine that there's another point here. There's a point y1. And for this y2, we have its corresponding coordinate as x1. And then you also have this one here as your coordinate x2. Okay? So let's imagine we have something like this. So let me change this a little bit here. Let me make this one here. Let's make this one y1 and y2. Do you remember this? We said that the b in the equation, this one here, we said that b there is what we call the slope or the gradient. And we said that to estimate that b or that slope or gradient, we said it represents a change in y, as you can see here. from y1 to y2 is a change in y, divided by a change in x. And as you can see below here, this is a change in x right there. And we said that that change in y can be written as increase in y divided by an increase in x. And we can still rewrite that as y2 minus y1 all divided by x2 minus x1. So that's the slope. The b part here is known as the slope or the gradient of that linear function. And that b, for a linear function, for a straight line, a linear function is similar to what we call a straight line. A straight line. So for the slope of any straight line, no matter the points that are picked on that straight line, the slope is always going to be the same. I'll take it again. If you pick, let's say, this point here and another point here, the change that you are going to get here, the slope that you're going to, or the gradient you're going to calculate here, is going to be the same as the one that we have calculated before. So we know that the b is going to be same no matter what. Is same no matter what for a linear function. But you know, for today's video, we are looking at differentiation. We're looking at calculus, specifically differentiation. All right. So if we talk about a non-linear, let's say a non-linear function, Okay, and let's imagine that we are having that non-linear function as this. Let's say it's a curve like this. So let's imagine for a second that we have a point here, we have another one here, we have another one here. You can tell that the b is going to be different. The b, which is the changes in y over the changes in x, will be different. It's not going to be the same as the linear function. It's going to be different. And for us to be able to estimate correctly what the slope of that particular nonlinear function is, we need differentiation of calculus. That is why we need calculus, to be able to estimate what the changes in y, over the changes in x. And we do not, in differentiation, that change in y over change in x is what is usually known as dy dx. dy divided by dx, but it's normally pronounced, it's usually pronounced dy dx. So that brings us here. So imagine that we have dy dx as our differential of a function or expression. Okay? What it means is that this is the same as y1, which is the same as y prime. Normally we say y1 is usually pronounced y1 or y prime. And that y1, this y1 that is pronounced as y1 or y prime is the same, can be written as dy over dx or dy dx. And we are saying that that is our first derivative. It's known as the differential of the function, or the differential of a function, or what is known as the first derivative. It's known as the first derivative or the first derivative. So we can have what, a second derivative by rewriting this. So this is going to be y2 is going to be d2y over dx squared. That is what, differentiating the first derivative. So this is called what, the second derivative. I'll write it here, the second derivative, or the differential. We can say it's known as the differential of y1. I hope this is clear. So differentiation is critical, is very, very critical because of finding the smaller changes on a curve or anything that is nonlinear. And then we said that the y prime or y1 is the differential of a function. And then we're also saying that it's also known as the first derivative. So the y dx is a differential of a function and is the same as y prime, pronounced y1 or y prime. And this y1 or y prime is the same as the y dx, which is known as the differential of the function or the first derivative. Now we said y2 or y2 is the same as the 2y over dx squared, which is the differential of y1, known as the second derivative. Okay, so I hope we are getting where differentiation, came about. Now let's quickly look at some rules. But we'll be going more into detail. Rules. We'll do a separate video for the rules of differentiation. But I want to run us quickly through the rules, how we're going to use differentiation, rules of differentiation. I'm going to run us through this one very quickly. Now, the first rule there says that if you have, let me pick the yellow. If you have, let's say we have y is equal to a multiplied by x to the power of n, we are saying that the y prime, right? We are saying that the y prime or y1, which is the same as the y over dx, is the same as multiplying the a, this a, by this n. We multiply a by n, and then we have the x. We subtract 1 from the index of the x. So it will be x to the power n minus 1. And that is going to give us an multiplied by x to the power n minus 1. That's the first rule of differentiation. The second rule has that if we are to have y to be a, and we are saying that the a is a constant can be 2, it can be 3, it can be square root of 5. It's just a constant without any variable. So if you have a constant, right, we say that when we take the y prime, or we differentiate a constant, when we take the y prime, or we differentiate that particular constant with respect to x, it's going to give us 0. It's one of the rules. I hope you're seeing where we are getting at. Now, the third rule is known as the chain rule. It's known as the chain rule. And it says that our y1, which is y prime, is equal to dy over dx, is going to give us the chain rule. We're on chain rule. It's going to give us dy over du multiplied by du over dx. Please, we are going to go deeper into the rules of differentiation in a separate video. Okay, but for today, I'm just running us through the concept of calculus. One of the two branches, we have differentiation and integration, but we are focused solely on differentiation for now. And we've looked at the significance of differentiation, and we are quickly going through the rules of differentiation. But in a separate video, we'll be going deeper into the rules of differentiation. Now, the fourth rule is known as the product rule. The fourth rule is known as what we call the product rule. And for product rule, we are saying that if you take your y prime, which is the same as dy over dx, we are saying that it's the same as u multiplying dv over dx, which is the differentiation of v as a function with respect to x. And we are adding it to v, a function, multiplied by the differential of u with respect to x. So multiplied by du over dx. Now the last one, I believe, the last rule is what we call the quotient rule. The last one is known as the quotient rule. So we have the fifth one, known as the quotient rule. And with the quotient rule, We take it again that with the quotient rule, we are having y prime, which is dy dx, as v du over dx minus u dv over dx, all divided by v squared. All divided by v squared. So we're going to end here. And as we're ending here, please, if it's your first time come in contact with our channel or you haven't yet subscribed, please do us a favor to subscribe so we can grow this family together. Because the goal of this channel is to make tutoring, yes, is to make tutoring very, very easy and enjoyable. If you have specific topics that you want us to do a video on, please feel free to drop it in the comment section and we'll be more than willing to do that just for you. I'll come back to you another time. Please take care and bye.